Today we're going to learn how to solve two-step equations. Just like with one-step equations, we would have to use inverse operations to get the variable by itself. But in a two-step equations, there's more than one operation that you'll have to use. So to figure out how you solve them, you're going to need to use the order of operations in reverse. That means that you would actually add or subtract first. So you would get rid of any addition or subtraction by using the inverse operation. Then you will get rid of multiplication or division by using the inverse operation. When you're finished, just like we did with one-step equations, you can check your answer by substituting your answer in for the variable in the original equation. Let's look at some examples. A says 4x plus 5 equals 29. Well, if I look at this, I have my equal sign and my x is on the left side. Well, I notice that on the left side of my equation, it says 4x plus 5. Well, that means x is being multiplied by 4 and it's being added to 5. So I would need to figure out what I would do first. Well, I would need to use the order of operations in reverse, which means I would need to get rid of the adding 5 before I get rid of the 4. The best way to remember it is you get rid of the number that is not stuck to the variable. So since that 4 is stuck to the variable, you would need to get rid of the 5 instead. So I'm going to get rid of adding 5 by using the inverse of adding 5. Well, the inverse of addition is subtraction. So I am going to subtract 5 from both sides of this equation. 5 minus 5 cancels to leave me with 0. And if I do 4x plus 0, that's just 4x. So you'll notice that unlike within a one-step equation, I'm not left with the variable by itself after the first thing. So I'll have to do another step. 29 minus 5 gives us 24. Well, now my equation says 4x equals 24. We know that 4x means 4 times x, so we would need to use the inverse of multiplying by 4. The inverse of multiplying by 4 is dividing by 4, so I am going to divide by 4 on both sides of my equation. My 4's will cancel because 4 over 4 leaves me with 1, and 1x is just x. And then 24 divided by 4 is 6. So that means that x equals 6. I can check this by putting it in my original equation, which said 4x plus 5 equals 29. Well, x is 6, so I would do 4 times 6 plus 5 equals 29. 4 times 6 is 24, and I would do 24 plus 5 equals 29. When I solve 24 plus 5, I would get 29. So since this is balanced, that means my answer of x equals 6 is correct. B says x over 5 minus 7 equals 5. Well, I need to get x by itself, and I notice that x is being divided by 5 and subtracted by 7. So I know that I need to get rid of adding or subtracting first, which means I need to get rid of my subtracting 7. Well, the inverse of subtracting 7 is adding 7. So I am going to add 7 to both sides of this equation. Negative 7 plus positive 7 is 0, so these cancel out, and I'm left with x over 5. Then 5 plus 7 is 12. Well, since I have x over 5 equals 12, now I just need to get x by itself by getting rid of the 5. Well, I know that x over 5 means x divided by 5, and the inverse of dividing by 5 is multiplying by 5. So I'm going to multiply by 5 on both sides of this equation. I'll be left with x equals, and then 12 times 5 is 60. So I have x equals 60. I can check this by plugging it in my equation. My equation said x over 5, so I got 60 for x, so it's 60 over 5. Then minus 7 equals 5. Well, 60 divided by 5 is 12. So then the rest of my equation says minus 7 equals 5. 12 minus 7 is 5, and since I get 5 equals 5, that means that my equation is balanced, so my answer of 60 is correct. Now let's look at C. 2x minus 9 equals negative 3. Well, I know that I need to get rid of my adding or subtracting first. So since I'm subtracting 9, I need to add 9 because that is the inverse of subtracting 9. And I'm going to do that on both sides of my equation. Negative 9 plus positive 9 is 0. So those cancel to leave me with 2x equals negative 3 plus positive 9 gives me positive 6. Now I need to get rid of the 2. I see that the 2 is being multiplied by x, so the inverse of multiplying by 2 is dividing by 2, which I'm going to do on both sides of this equation. These will cancel to leave me with x equals, and then 6 over 2 is 3, because 6 divided by 2 is 3. So that means x equals 3. Now, I'm not going to show you how to check these because by now you should know how to check your answers, but you always want to go back and check your work to make sure you did it correctly. D says x over 4 plus 2 equals 5. I know I want to get rid of my adding or subtracting first, so I need to get rid of this plus 2. I'm going to use the inverse of adding 2. So the inverse of adding 2 is subtracting 2, and I'm going to subtract 2 from both sides. 2 minus 2 cancels to leave us with x over 4. 5 minus 2 is 3. Now I'm left with x over 4 equals 3. Well, I still need to get rid of this 4, so I see that x is being divided by 4. The inverse of dividing by 4 is multiplying by 4. So I'm going to multiply by 4 on both sides of this equation. These 4's will cancel to leave me with x equals, and then 3 times 4 gives me 12. So that means that x equals 12. E says 6 plus 2x equals negative 6. Well, I need to get x by itself, so I need to start by adding or subtracting. Well, I see that 6 is being added to 2x, so I'm going to use the inverse of adding 6, which is subtracting 6. And I'm going to do that on both sides. 6 minus 6 cancels to leave us with positive 2x. Now, negative 6 minus 6 you have to be very careful with because an easy mistake to make here is to say that that is 0. But it's actually not. If you put that in your calculator, negative 6 minus 6 is actually negative 12. Now I need to get x by itself. I see that x is being multiplied by 2, so I need to use the inverse of multiplying by 2. The inverse is dividing by 2, which I'm going to do on both sides. These will cancel to leave me with x equals, and negative 12 divided by positive 2 is negative 6. So x equals negative 6. For f, I have 7 plus x over 3 equals 4. I need to get rid of my adding or subtracting first, so I'm going to get rid of my 7 first. I see that that's a positive 7, so to get rid of it, I am going to subtract 7, because 7 minus 7 is going to give me 0. Then I'm left with positive x over 3 equals, and 4 minus 7 is negative 3. To get x by itself, I need to get rid of this 3. I see that x is being divided by 3, so I'm going to use the inverse of dividing by 3, which is multiplying by 3 on both sides. These 3's will cancel to leave me with x equals, and then negative 3 times positive 3 is negative 9. So that means x equals negative 9. Now let's look at the next set of problems. G says negative 8 plus 4x equals negative 20. So we're starting to look at some negatives here. Well, again, I know I need to get rid of my adding or subtracting first, so I'm going to need to get rid of this negative 8. And I want you to pay very close attention here. Negative 8 is being added to 4x, but I'm not subtracting 8. I actually have to look in front of this 8, and I see that there is a negative. Well, that is the same as saying minus 8. So to get rid of it, I would do the inverse of negative 8, which is positive 8 or plus 8. And I'm going to add 8 on both sides. The reason I do this is so that these will cancel, because if I do negative 8 plus positive 8, I get 0. But if I had subtracted 8 here, I would not get 0, so they wouldn't cancel out. So these cancel now to leave me with positive 4x, which I know is positive because of this plus sign, and then my equal sign. And negative 20 plus positive 8 is negative 12. So now I have 4x equals negative 12. I know that 4x means 4 times x, so to get rid of the 4, I'm going to use the inverse of multiplying, which is dividing by 4 on both sides. These 4's will cancel to leave me with x equals, and negative 12 divided by positive 4 is negative 3. So x equals negative 3. Now h says negative 10 minus 6x equals 32. I need to get x by itself, so I need to get rid of my adding or subtracting first, which means I need to get rid of this negative 10. Well, because the 10 is negative, the inverse or the opposite of that is plus 10. And I'm going to add 10 on both sides. Well, negative 10 plus positive 10 is 0, so these cancel. But I want you to pay very special attention right now. I am not left with 6x. There is actually a minus sign in front of that 6x, which means I'm really left with negative 6x. Then I have my equal sign. Now 32 plus 10 is 42. So my equation that I'm working with now is negative 6x equals positive 42. I know that negative 6x means negative 6 times x. So to get rid of the negative 6, I'm going to use the inverse, which is dividing by negative 6 on both sides. These will cancel to leave me with x equals, and positive 42 divided by negative 6 is negative 7. So x is equal to negative 7. I says 12 minus 3x equals 3. I know that I need to get rid of the 12 first. Well, I see that that's a positive 12. So the inverse of that is subtracting 12 from both sides. A common mistake here is that you see this minus sign, so you want to add 12. But if I did 12 plus 12 here, I would get 24. Well, I'm not trying to get 24. I'm trying to get rid of the 12. So when I do 12 minus 12, I'm left with 0, so they cancel each other out. On this side, I'm not left with 3x. I'm left with a minus 3x, which means this is negative 3x. Then I have my equal sign, and I'm going to solve 3 minus 12. Well, 3 minus 12 is equal to negative 9. Now I need to get x by itself by getting rid of this negative 3. Well, negative 3x means negative 3 times x. So the inverse of multiplying by negative 3 is dividing by negative 3, which I'm going to do on both sides of this equation. These will cancel to leave us with x equals, and negative 9 divided by negative 3 is positive 3. So x equals 3. For j, you see 5 minus x over 4 equals 4. I know that I need to get rid of the 5 first. So because that is a positive 5, I am going to subtract 5 from both sides. 5 minus 5 will cancel, and I'm not left with x over 4. I'm actually left with negative x over 4. And then equals, and 4 minus 5 is negative 1. Well, if you remember from what we worked with fractions, if you have x over 4 and the whole thing is negative, that means that either the x is negative or the 4 is negative. Well, if I get rid of the 4, that negative is still going to be with the x, so it's not going to be by itself. So that means I could rewrite this as x over negative 4, which means the same as this. Well, when I do that, then I can get rid of negative 4, and then x really would be all by itself. So that means that since this says x divided by negative 4, I would need to multiply by negative 4 to get rid of it. So I'm going to multiply by negative 4 on both sides of this equation. These would cancel, and now I really would be left with just x, and negative 1 times negative 4 is positive 4. So x equals positive 4. K says negative 6 minus 8x equals negative 22. I know that I need to get rid of this negative 6 first. Since it's negative, the inverse or the opposite is going to be adding 6. So I'm going to add 6 on both sides. Negative 6 plus positive 6 is 0, so these cancel out. Now, what I'm left with is not 8x. You see that there's a minus sign here, so I'm really left with negative 8x equals, and then negative 22 plus positive 6 is negative 16. Now I can divide by negative 8 on both sides, and I'm dividing because my equation says negative 8 times x, and the inverse of multiplying by negative 8 is dividing by negative 8 on both sides. These will cancel to leave me with x equals, then negative 16 divided by negative 8 is positive 2. So x equals positive 2. L says x over negative 11 plus 14 equals 10. Well, in this one, I have a dividing by negative 11 and an adding 14, and it all equals 10. I want you to use the inverse operations here to solve and tell me what x equals. To solve this, I would subtract 14 from both sides because I know I would need to add or subtract first. Well, 14 minus 14 cancels and leaves me with x over negative 11 equals, and then 10 minus 14 is negative 4. Then I need to get x by itself, so I need to get rid of negative 11. Since x is being divided by negative 11, I'm going to use the inverse of dividing, which is multiplying by negative 11 on both sides. These will cancel to leave me with x equals, then negative 4 times negative 11 is positive 44. So for this, I get x equals positive 44. Now I want you to try m. For m, the first thing I need to do is get rid of this negative 5. So the inverse or opposite of negative 5 is adding 5, which I'm going to do on both sides. Negative 5 plus positive 5 cancels to leave me with positive 7x. And I know that it's positive because of this plus sign. Negative 75 plus positive 5 gives us negative 70. So now I have 7x equals negative 70. Well, I know that 7x means 7 times x. So the inverse of multiplying by 7 is dividing by 7, which I'm going to do on both sides. These will cancel because 7 over 7 is 1 and 1x is just x. Then I'm solving negative 70 by positive 7. Negative 70 divided by positive 7 gives me negative 10. So x equals negative 10. Finally, I have n, which says negative x over 6 minus 4 equals 16. Well, remember, if I have negative x over 6, that's the same as the negative being with the 6. So I could rewrite this as x over negative 6. Now I want you to solve this. You can rewrite it like this first, and then solve this and put your answer in the chat. For this problem, I would need to get rid of the minus 4 first. So the inverse of subtracting 4 is adding 4 on both sides. These would cancel to leave me with x over negative 6 equals, and then 16 plus 4 is 20. Now I see x divided by negative 6, so I'm going to use the inverse, which is multiplying by negative 6 on both sides. Those would cancel to leave me with x equals, and then positive 20 times negative 6 is negative 120.